Hello everyone. Now in this class we are going to discuss what is mathematical modeling and what is modeling linear growth and modeling linear decay, and we will do some related problems on this topic. So let's begin the topic now. First we come to know what is modeling in mathematics. So suppose we have a real life problem, and when we use the mathematics to represent it or to explain it, to describe the situation in a simplified way, so that process is called the modeling. Okay now. So now there are two types of modeling. One is known as linear growth, another is linear decay. So in case of a linear growth, what does it actually mean? Suppose a quantity increase in such a way so that for this increment occurs constantly over the equal time intervals. For example, suppose from 1 hour, and it is 2 hour, it is 3 hour. So in 1 hour unit, duration of 1 hour, the changes, suppose from here to here, this height is 4, this height is 6. So now in 1 hour duration, you notice that 6 minus 4, the changes in the quantity is 2 unit. And again, if it is at the point 3 at 3 hours and this is 2 hours, the duration is 1 hour. So in this 1 hour duration, if you notice that this height is suppose 8. So in this 1 hour duration, 8 minus 6, the changes is again 2 unit. So what we come to know that the linear growth occurs when a quantity increase by the same amount over the equal time interval. So this may be the time interval or other some quantity like x, this quantity will be y. So changes in y is fixed over the 1 unit change in x. I hope this part is clear. So when we represent this linear growth in a graph, the graph will be the straight line pointing upward. So always it will be the pointing upward. When we move from left to right, it's just like you are climbing the mountain. So when we move from left to right, it's look like you are climbing on the mountain. So it is pointing upward. It is a straight line which is pointing upward. When we have its algebraic expression, it will be look like y is equal to mx plus c, where this growth factor is always positive. It is nothing but the slope, or you can say that rate of change in y with respect to the x. Okay now. So for example, if I have y is equal to 2x plus or minus 5, then this straight line is always pointing upward. When we move from left to right, it's look like we are climbing on a mountain. Okay now, since here this slope is positive, it always be increasing. Okay now, this is also known as the growth factor. Okay, here are some examples. Suppose in a bank, piggy bank, if you put 50 rupees in a bank per month, so in 8 months you can save 15 to 8, that is 400 rupees. Okay now, instead of x month, if I take x month, then we can save 50x. Okay now, 50x, this amount we can save for x month. Now it is nothing but a linear growth. We have something positive, and suppose our amount will be denoted by y. So after x month, I have 50 times of x amount in our piggy bank. Okay now, similarly in physics, if an object moving at a constant speed of 40 km per hour, then the distance traveled in 40 hours will be 40, then the distance traveled in 40 hours, it will be 40 hours. So it will be 40 times of 40 kilometers. Okay now, like this. And if you consider x hours, it will be 40 times of x. Okay now. Now total revenue from selling x items at a fixed price 4 is 4 times of x. Okay, so these are the examples of modeling linear growth. Same we have the modeling linear decay. Suppose we consider over equal interval of time 1 2 3 hours. In 1 hour the height is here, in the second hour the height is here, and third hour height is this one. So this height, if I consider 8, this one is 6, and this one is 4. So you notice that when you join this line, you will have a straight line which is pointing downwards. It's look like when we are moving from left to right, it is just we are coming down from the mountain. Okay now, so in 1 unit duration the amount decrease from 8 to 6, that is 2 unit. Okay now, and from here the amount decrease 6 to 4, again 2 unit. So that means linear modeling linear decay occurs when the quantity decrease by the same amount. The quantity decrease by the same amount over the equal interval of time. Okay, now this may be the time or some other variable you can take along the x-axis, some other variable in y-axis. So that means I want to say that the rate of change of one quantity with respect to the other quantity is negative. You start with an initial value and subtract a fixed amount repeatedly. That is the concept here. Suppose this line is nothing but 1 minus 2x plus something like 10. Okay now, so if I have this type of things, then here the m value is negative. So when m is negative, automatically you have to think about the line which is pointing downwards. Okay now, take some real life examples. Fuel consumption. Suppose in your car you have 250 liters petrols. Okay now, it consumes 40 liters per hour. So in 1 hour how many liter consumes? 40 hours. So for x hours you have to consume 40x liter petrol. So after x hour, what amount of petrol left in your car is 250 minus 40x. Next example, suppose your father has given you rupees 100 as a pocket money, and if you spend 2 rupees each day, then the remaining amount after x days will be this one, because every day you have to spend rupees 2. For the x day it will be 2x amount. Now after x day you have given initial value minus the amount that you have spent. Now suppose you have a cup of coffee or a tea and its temperature is given like suppose 100 degrees C. Okay, 100 degrees C, and every 1 minute the temperature suppose some temperature is decreasing at the rate of 10 degree per minute. Okay, now 10 degree per minute. So you notice that initially the temperature of the tea is 100 degree, and every 1 minute it decreases by 10 degree. So after x minute the temperature will be 10x minus. Okay, now the final temperature will be y is equal to 100 minus 10x degree. My question is, after how much minute the temperature will be the 0 degree, that it's look like a coldness as ice. The time will be 10 minutes. So after 10 minutes your temperature of your tea will be 100 minus 10 into 10, that is 0 degree. It's similar to just like temperature of ice. Now there is the key difference between the linear growth and linear decay. So when you have, they have the same general form, mx plus c, but in case of a growth it will be positive, m is positive. In case of a decay it will be negative. Its direction is pointing upward, just like you are climbing the mountain. Here you are just downwards, just coming down from the mountains. Its trend is increasing. It indicates that the one quantity is increases gradually, and it indicates the decreasing value. Simple interest you have earned, and here the example is depreciations of a machine, or suppose you have a mobile, its depreciation starts after your purchasing. Okay, now these are the few things. So today what we have done in a theoretical part, what is mathematical modeling? So it is nothing but it is the simplified representations of the system. We have one problem, we mathematically represented it in a simple way. Then we came to know that the types of linear model, one is the model linear growth, another is the model linear decay. Okay, now so here in case of linear growth, the growth occurs constantly. That means the value increases by the same amount over the equal time interval, and there in decay the value decrease by the same amount over the time interval. Then we have the common difference between the decay and the growth, and their graph we have no. Now coming to this part, we have some questions, multiple question, which best defines the modeling. Commercial photography, absolutely not. Simplified representation of a system, it is okay. 3D clay sculpting, obviously not. Rote memorizations, it is obviously not. Linear model, this one is given. Then what is this m? It is rate of change. Obviously it is the rate of change. It may be the growth if it is positive. For the positive, m must be greater than 0. It will be decay if m lesser than 0. That means my choice is D. All of the options are correct. Coming to this one, which graph shows a linear decay? So according to this graph, when you move from left to right, which graph shows that you are coming down on the mountain? So this one only, that is the pointing downwards. Which equation shows a linear growth? Linear growth is what? It is a straight line. Okay, now so which equation shows a linear growth where the slope should be positive? So here the slope is negative, linear decay. Here the slope is positive, it is linear growth. It is the mod function. It actually does not indicate the linear growth or decay over the domain, and it is absolutely here the m value is 0. So my choice is Bombay. Here we have m which is positive. Okay, now for linear growth or decay model, the initial value is obtained by putting the value of x is equal to 0. So we have, suppose this type of curve. So we want to know what will happen at 0. So this value is the initial value, and this is obtained by putting x is equal to 0. Now coming to this one, a rising straight line represents what? It represents the growth. A falling straight line represents the decay. A horizontal line represents zero growth. If the line is look like horizontal, so m value is 0. There is no change in m value. That means if I take here 1 hour, here 2 hours, here 3 hours, so at the first hour the height is here, second hour is height is here, they have the same height, so their changes is 0. There is no change in the height, and third hour also there is no change in height. The overall growth is 0 for the horizontal line. A line does not represents growth or decay. That line is called what? It is the vertical line. Suppose it is our axis, and if I have this vertical line, so what we observe that there is no scope for the time interval. In 1 hour we have here, but in second hour there no value is given. So that's why this type of straight line, which is the vertical line, or you can say that parallel to the y-axis, does not represent the growth or decay. X is equal to C is not a relationship. It is not a linear relationship. X is equal to C means the line which is parallel to the y-axis. Okay now, and this line does not represents the linear relationship because it does not indicate any change in x value. Okay now. Now here the answer is also given, no issue. Coming to this part, water is flowing from the tap at a constant rate, and is this growth or decay? So you have some initial amount here. Now after at a certain rate the water coming out, that means you have a decay here. You have the decay. You can calculate if the rate of the water coming out from the tap is given. Suppose V liter water coming out per hour. So that means we have the equation. If it is suppose the given quantity, if it is given as 250 liter, then we have 250 liter minus V into some x hours, we have this one. So therefore this is a decay. Okay now? A car is moving at a speed of 60 km per hour. Find the distance traveled in x hour. It is 60x, so it is the linear growth. Every x hours or every increment in the 1 hour, there is a certain increment in the distance. Does the graph correspond to the equation 2 represent the linear decay or linear growth? It indicates the linear growth. Does the fact that y increases as x increases necessarily imply a linear relationship? Obviously not. For example, if I have this kind of graph where you notice that suppose this is the graph of y is equal to 2 power x. So for first hour the height is 2, but for the second hour height is 4, and the third hour you notice that height will be 2 power 3, that is 8. So now the difference is, first difference is 2, second difference is 4. So that means every time if the change in the y variable is same 1 unit, but not the change in the x variable equal amount. That's why every time the same increment in the x-axis along the x-axis not necessarily imply the linear relationship. So now does it imply? Answer is no. Identify the linear growth. So there are two curves given. One curve, that is C1, look like this. Another is the straight line. This one is the straight line. So every straight line represents something that is known as either growth or decay. So here it is pointing upward directions. It will be the growth. So growth denoted by C1. Why not by C2? Because it is not a straight line, it is a curved line. Short answer type questions. Find the value of y in the equations. Two scale is given, centigrade scale and Fahrenheit scale. Oh, I think this picture for this second questions. Now find the value of y. So just put here x value, that is 16 plus 12, so it will be 4 into 4, 16 minus 12, that is 0. Okay now? Very simple questions. Next is Consider the linear relationship between the centigrade and Fahrenheit scale. Formula for centigrade to Fahrenheit. Suppose you want to convert centigrade temperature to a Fahrenheit temperature. What you have to do, just first do the cross multiply. 5 into F, it is 5F, and 5 into 32, 160 is equal to 9C. Next I have 5F is equal to 9 times of C plus 160. Now F value will be 9 by 5 over C, 9 by 5 multiplied by C, then 160 by 5, and it is 32. Okay, now so this formula we have to utilize for converting centigrade temperature to Fahrenheit temperature. If two straight lines have opposite slopes, then what they represent? Give example. Suppose one line is half of x plus like 5, and another line I have minus half of x plus 5. So what you notice that one is positive half, another is the negative half. So now the lines have opposite slopes, they have the opposite slopes, so it indicates the growth, and this indicates the decay. Okay, now so what they represent? Give example. So one represent the growth, other line represent the decay, which has the negative slope. Question number 4 is similar, you can solve at home. Based on Charles' law is what? Relationship between the volume and the temperature when the mass of the gas is constant. Why is the graph does not pass through the origin? So if it pass through the origin, but in the graph you notice that when you have the 0 degree temperature, then you have some value. So at 0 degree we have some value, 0 degree centigrade. So if the volume is 0, then the curve is passing through the origin, but in our case the volume is not 0, that's why it is not passing through the origin. What is the relationship between the volume and temperature? So it is the modeling linear growth, because you notice that it is pointing upward direction. So every straight line represents either growth or decay, but here it is pointing upward, so it is the linear growth. This relationship is given by or denoted by this line segment. Coming to the next one. Long answer questions. A local fitness center charges one-time registration fee plus a fixed monthly membership fee. After 3 months, the total cost will be this one, rupees this, and after 7 months, the total cost is rupees this. So here we don't know what is the monthly charges, okay now, and we don't know what is the fixed charges. So I am taking this straight line y is equal to mx plus c. This is my linear growth modeling. So here a local fitness center charges one-time registration fee. This is my fixed amount, registration fee, that is the fixed value, and my monthly charges is m. This is the monthly charges, m for monthly charges, and x indicate the month, number of month. After 3 months, so when x is 3, I have 3m plus c, and this value will be the total cost is 3500. This is number 1. And after 7 months, so when x is 7, I have 7m plus c, and in that time total cost is 6700. So I have 2 equations and 2 unknowns. Can we find c and m? obviously we can calculate, just do the subtraction. What we get, CC cancel out, 3 minus 7 minus 4m, and here we have 6700 3500. So 0023, so 3200 with negative sign. Negative negative cancel out, m is equal to 800. So m value you have got. Now put this m value either in the equation 1 or 2. So it will be 3500. From the 1 I have 3500 is equal to 3 into 8, 2400 plus the value c. So if you subtract, you will get 1100. That is the value of c. So now we can find out it is equal to 800 times x plus the fixed charges for the registration. I hope this part is clear. Determine the monthly membership fee. So monthly membership fee is this one, and fixed charges is this one. Write the linear model for the total cost y after x month. So after x month, this one is the total cost. How much would it cost for fully year? That means when you plug this 12 here, you will get the total amount. So y is equal to 800 multiply 12 plus 1100. So it is 9600 and plus you have 1100. So it will be 10,700 is the total 1 year fees. I hope this part is clear to everyone. Now coming to the question number 2, you can do it. It is similar to the previous questions, and just here you have to use the minus sign. For the m, you have the linear decay. Compare this model and explain the difference in their graph. Okay, now so you notice that when x is 0, you have a line which intersect x-axis, which intersects y-axis at the point 1. So when x is 0, so you have when x is 0, y is 1. Now when I have put y is equal to 1, then x is 0. Y is equal to 1, then I have x is equal to 0. Y is equal to 1, x is equal to 0 here. Okay, now so first I put x 0, then y 1, x 0, y 1. Okay, if x is 1, then 3 by 2. Okay, y value is 3 by 2. Slightly mistake here in calculation. Okay, when you put x is equal to 0, you get y is 1. When you put x is equal to 1, okay, either you can put y is 1 also, then y is 1 indicate half of x plus 1 is equal to 1. That means half of x, 1 minus 1, 0, then x is 0. So when x is 0, y is 1, like here. When x is 1, y is 1, then x is 0. Oh, y is 1, x is 0 we have already taken. Then you take y 0. If you put y 0, so it will be half of x plus 1. That means half of x is equal to minus 1. X is equal to minus 2. So when x is minus 2, like here, then you have y value is 0. So for the first curve, you join like this one. Okay, this is for L1 curve, where m1 is equal to half. Okay, now here when you put x0, y is also 1, and when you put y is 1, then you have 1 x is 1, when you put x is equal to y equal to 0, okay, when you put y is equal to 0 in the second equation, then what we have, y is 0 implies minus half of x plus 1 equal to 0. That means x is 2 only. So now we have to take the point here for the second curve. It will be look like point will be here. So we have when x is 2, y is 0. When x is 2, y is 0, so another line will pass through like this one. So here you notice that the magnitude of this m, not magnitude, the slope will be minus half. The slope will be minus half. Okay now. Okay. So now one indicates this line L1 and this line is L2. So what they indicate, when I plug x is 0 here, then both have the same initial value. So both the curve, my observation, both the curve have same initial value. They have the same initial value. Both the curve has same initial value, that is 1. Y is equal to 1. The L1 indicates the linear growth. Other one indicates the linear decay because it is pointing downwards and it is pointing upward, and explain the difference in their graph. So these are the difference in their graph. One more question is given. The relationship between the centigrade and Fahrenheit is given this one. So this is nothing, you have to solve at home. Which temperature is same in both scale? For this purpose you can write C is equal to F is equal to X late. Now you can plug the value of CF as X and you can find out this value will be minus 40. So this minus 40 degree temperature will be same in both the pair. Now explain why it represents growth or decay. So this type we solved in the previous question, like here in the centigrade and Fahrenheit temperature, like this one. So when you represent Fahrenheit temperature and centigrade relation like this, so you can consider this is your y and this C is X. So what you observe that M is positive. M is positive. Now you can apply this here for this purpose. Explain why it represent the growth, because here M, whatever you get there, that quantity is positive, that is C by 9. Okay now other part you can solve easily, and this part is the homework. Now we will meet again in the another part and we will do a lot of problems and conceptual things. Bye, have a nice day. Point will be here. So we have when x is 2, y is 0. When x is 2, y is 0, so another line will pass through like this one. So here you notice that the magnitude of this m, not magnitude, the slope will be minus half. The slope will be minus half. Okay now. Okay. So now one indicates this line L1 and this line is L2. So what they indicate, when I plug x is 0 here, then both have the same initial value. So both the curve, my observation, both the curve have same initial value. They have the same initial value. Both the curve has same initial value, that is 1. y is equal to 1. The L1 indicates the linear growth, other one indicates the linear decay because it is pointing downwards and it is pointing upward, and explain the difference in their graph. So these are the difference in their graph. One more question is given. The relationship between the centigrade and Fahrenheit is given, this one. So this is nothing, you have to solve at home. Which temperature is same in both scale? For this purpose you can write C is equal to F is equal to X late. Now you can plug the value of CF as X and you can find out this value will be minus 40. So this minus 40 degree temperature will be same in both the pair. Now explain why it represents growth or decay. So this type we solved in the previous question, like here in the centigrade and Fahrenheit temperature, like this one. So when you represent Fahrenheit temperature and centigrade relation like this, so you can consider this is your y and this C is X. So what you observe that M is positive, M is positive. Now you can apply this here for this purpose. Explain why it represent the growth, because here M whatever you get there, that quantity is positive, that is C by 9. Okay, now other part you can solve easily and this part is the homework. Now we will meet again in the another part and we will do a lot of problems and conceptual things. Bye, have a nice day.